Hey y'all, Data Guy here. So, at the request of one of my viewers who wanted to see kind of some more advanced machine learning techniques, I've wanted to make a video on something that one of my colleagues at Astronomer made, Michael Gregory, which is kind of an example training DAG for training a machine learning model within the context of Snowpark and Snowflake. So this is a pretty advanced model. So instead of kind of doing the model, or not the model, sorry, the format of saying, hey, everyone, we're going to start from scratch. With this one, it's so massive that it would be just kind of impossible to start from scratch. And so what I want to focus on in this video is just kind of highlighting how this DAG is structured and really walk you through a, production ready use case for machine learning and show you, what needs to go into it. And this is repo is also structured in such a way that all you need is just a Snowflake account, which you can create a free trial, run this yourself, and then I'll show you, where you can do this later. But if you want to customize it, change the model out, maybe bring in some of your own data, um, you can do that as well. So really think of this just kind of as a format that you can use and adjust to your own particular use case. Rather than thinking, hey, I got to build this all from scratch. And the reason why is because this is going to be using just a ton of new features that it's almost harder to see them in isolation than it is to see them all working together at first because they're so reliant on each other. So some of the things that we're going to be going through is a Snowpark provider for Airflow, which is just going to allow us to run Python code within Snowflake. We're going to ingest data with the Astronomer Python SDK for Airflow, do audio file transcription with OpenAI Whisper, so bring in some audio files, use OpenAI Whisper, which is an API endpoint that will transcribe your audio files into plain text, then use embeddings, which you can think of kind of as a condensed version of your text. So it's just formatted so, hey, instead of needing to read all this text, every 4 words, right, is condensed to one vector. And so your model can ingest all that language much quicker because it can say, hey, this vector is saying move data to cloud, and it's only represented by this is obviously in real life, but like a keyword that's just OLAP. Um, and then we also have the Weaviate provider, which is a database that is designed strictly to hold those embeddings and those vectors. And so then you'll see we'll use Weaviate for vector search. We're also going to show you how you can use the kind of Astro Dockerized way of doing things to just spin up a local Weaviate database. So you don't have to go set one up separately. Then we're just going to use sentiment classification. So this is just a particular model. We're going to use LightGBM. This is the one you can kind of swap out. And then we're also going to have show you how to use the Snowflake ML model registry. And so do some ML model management as well. So without further ado, let's get into it. So if you want to follow along, please download this repo, but I'm going to now head over to my own VS Code and kind of start walking through it. Okay, so now here we are in our local development environment. And so if you're starting from scratch, you maybe download the zip from GitHub if you're following along with me. You'll have a folder. I just renamed mine to Snowpark Final Stream, but you'll be something like Astro ML Demo. And so then what you're going to want to do after you do that, actually before you start it up, so before you do anything, kind of want to walk you through the file structure because it's actually really important here for doing ML work because kind of highlights how much extra infrastructure you need if you want to actually do machine learning in a production ready way. So first, we have our standard requirements where we're bringing in some of our machine learning operations. We're bringing in Streamlit so we can visualize some of this in a lightweight data application and check out some of my previous videos on Streamlit if you haven't already. We have Snowflake ML Python, our Airflow provider for Weaviate, and our Airflow provider for Snowflake. Then we have Pandas, scikit-learn, again, just for some data transformations and plotting, Altair, Matplotlib, just a lot of data manipulation related Python libraries. And then you'll notice we also have a separate folder for our Snowpark requirements. So your Snowpark requirement where you're going to be executing that Python code within Snowflake needs to have its own requirement files. So you'll need to actually have a separate requirements file to install when you're using Snowpark to install these and make them available for your data manipulation for whatever within Snowflake. And then within our packages, you'll need to have build essential. This will allow us to manage our virtual environments, and you'll see that next in our Docker file. And then FFmpg is just a repository, set of packages that allows you to handle audio files, in a more efficient way. That's a really big generalization about it, but if you want to get deeper, just look it up. It's pretty cool. And then we have in our Docker file, and this is where it gets kind of crazy, so I'll highlight this for a second. So here we have the syntax up here equals quay astronomer extensions latest. Make sure you have this. I actually deleted it by accident, and it makes this Pi environment operation impossible, because this is actually referencing an extension that automatically creates Python virtual environments with a specific version, with a specific name. So it's calling it Snowpark. And then it's installing our requirements snowpark.txt in there. So it's just a kind of utility function that Astronomer provides. Then we're setting our base version of Airflow to 3.10, our Python version to 3.10. And then because that's what you can do now, it's great. Then again, because these aren't officially available on pip, we're just copying the wheel files, and these files are in our include directory over here. So we're just copying them in, making them available, because we can't just pip install them like usual. So here they are, just in the include directory. And then again, creating that virtual environment like I said before, and then copying our requirements into a temporary directory and installing them within our environment. So super useful functionality here, just to kind of make it easy to spin up a Python and virtual environment that you're actually running your Snowpark queries to. And now the question that you might be thinking, why do I need a Python virtual environment to execute Snowpark queries? That is because Snowpark currently only supports 3.8 Python, which Airflow does not. So to execute queries in Snowpark, you have to create a 3.8 compatible Snowpark Python virtual environment and then execute it through there. Then we also have our Docker Compose override. So this is where we're actually going to set up Snowflake as our XCOM backend. So because we're processing so much data, having an XCOM backend that can handle a large amount of data than just the standard Postgres is pretty much necessary. So you're just creating our web server at 8501. Then you have our Weaviate database. This is, where we're storing that vector embeddings, and those again are coming pre-populated because someone's already made them up, but you can see the kind of process of how they're created as well within the DAG. And then what else do we have? So this is just set the backend, setting up our Weaviate service, and then we have our Snowflake connection. So here in the environment file, you can either set it within the environment file or in the connection UI. But if you set it in the environment file, you'll see this tab Snowflake, login. I have my data guide, then your password, all your different information, and you can go look through it yourself. Don't need to change anything with the connection to Weaviate by default, but if you want to enable kind of a chatbot feature at the end, you can add your OpenAI API key, and this will actually allow you to query that Weaviate information, which is pretty cool. And so that is mostly it. There is also just kind of some sample data, some SQL files in here that are left over, and then our Streamlit app. So if you want to spin up Streamlit, we'll show you how to do that at the end. And that is pretty much it. So now if we go into our DAGs, we have our customer analytics DAG. And actually, before I kind of get going into this, I want to actually walk this through within the Airflow UI, because if you just walk it through within this code, it's 800-900 lines, and it's just going to get really overwhelming. So here I'm just going to highlight, actually, before I go into the UI, just kind of some high-level things, and then I'll show off everything over the Airflow UI where it will actually work. So here I'm just importing a lot of the standard imports, pandas, numpy, datetime OS, then bunch of different Astro, SQL, AQL, file, table, metadata. This is just making it easier to pass data frames and files, set files to as inputs and outputs of tasks, pass them between. Just utility functions from Astronomer, standard Airflow decorators with the setup and teardown. So this will utilize setup and teardown to kind of eliminate any temporary tasks or temporary tables that are created, to store data before it gets processed. Porting utilities from Weaviate, so we can actually generate a UUID, and that'll become apparent later. So our Snowpark table, allowing us to import tables in Snowpark easily, and then we have our Weaviate restore operator, and this is going to let us restore that pre-baked data that comes included within this repo, so you don't actually have to pull it all yourself. So it makes it a lot quicker to actually run this. So now, kick it over to the Airflow UI and kind of walk you through what this looks like over there. So here, we tab over to Airflow UI. See, we have my customer analytics DAG. And so if we open it up, we can see it's quite a doozy. So if we open up this graph view, so actually, funnily enough, there's no more graph view. So if you hit graph view, it just opens you up to this kind of grid view. I'm going to break it down to you step by step and show you what's happening. So first, just zoom in here a little bit. Pull this over here. Cool. So at a high level, what's going on here is we have this create task, which is creating temporary tables for us to use during the DAG, and that's just to make this completely self-service. You don't have to create anything to actually run this. This will create all the tables it uses itself. Then we have this enter task group. You can see in the description here. This is basically it's doing a bunch of different setup tasks, and I'll break it down later, to bring in our Weaviate data, make it ready, create a model registry. Then we're bringing in some unstructured data, and this is things like reviews, calls, and then we're using this to train sentiment classifiers to see, hey, how our what's our customer sentiment look like based on their calls to support, based on Twitter comments, et cetera, et cetera. Then what we're doing is doing some sentiment analysis on this, figuring out what the sentiment is for our calls and for Twitter. And then we're pairing this with our structured data, which is telling us more information from our customers, pairing that together, then creating presentation tables that show us the relationship between a customer's lifetime value and how happy they are. And shockingly, there is somewhat of a correlation between a customer being happy and then spending lots of money on your product. So now going into each task group by itself. So here we have in this enter task group, and I'll break open the code here on the side. So I wish you could do both of them. So it's in the enter task group, which you just saw where that is within the DAG. You can scroll in here down into we have this is our create snowflake objects. This is creating all those objects I was just talking about. And then within this enter task group, what this will do first is download a Weaviate backup. And what this will do is basically just spin up a new Weaviate database with the information that's already been generated. So the vectors that represents unstructured data that makes it easier for OpenAI to actually ingest it. And we're using OpenAI embeddings to actually create those vectors. So here it's downloading that backup zip file and then making it available into a Docker mounted file system, which the Weaviate restore task will do, and then create a Weaviate local database based on that backup information. So here we're storing it. We're also creating a model registry if one doesn't already exist. So you can see kind of that check there. And then filling that with our Snowflake objects that we also created, so running after there. And then we have our Weaviate restore operator, where we are going to restore Weaviate from that backend we set previously. And then you can see ID backup, include all of our Weaviate class objects and replace any existing one. So here, restoring demo doc down, just restoring Weaviate markdown. Sorry, got lost my brain there for a second, where you can just all the data is brought back in. So super fun stuff. Then that is everything to go in the enter task. So again, just to kind of center you back where that's at. So we've entered in, brought back our data, brought back our structured, or brought back our unstructured embeddings. So now what we'll also do is walk you through structured data. So here, you'll notice within kind of the structure of this file group, you'll have your seven in parallel operations that are just loading structured data from various sources. So here you have, zoom in, you have subscription periods, ad spend, customer conversions, customers, orders, payments, sessions. So just all information about customers' spending patterns. And then you have those 3 SQL scripts I showed you earlier that are just transforming that data and combining it to make it readable and easily combinable with the end result of that sentiment analysis. So then we look at how this is implemented in the code. It's actually not as scary as you would think, because this is a great example of utilizing kind of task groups and a for loop to just dynamically create tasks to ingest files in parallel. So here you have for every source and data sources, load file, task ID, load file source, input file, output table. So this is, just makes it easy. This is the Astro function I was talking about earlier. Makes it easy to import a file and then output it as a table. And then you have a separate task group down here, which is a little more complicated, where we have our different transformation functions. So these are executing within Snowpark. So after our data has been uploaded into Snowflake, within our load function, this is going to actually execute Python code on our SQL data. You can read this explanation why that's useful here. But if you just want to look at it, you can see we're grouping by customer ID, and you can see just basic transformations on our different data sets that are just making our information on our customer spend more easily joinable with our information about what their customer sentiment is. So you can see just customer revenue by month. So just condensing it down to how much are these customers spending over the lifetime. So getting that, instead of just how much they're spending per month, condensing it down into one field. And you can see attribution playbook as well, where we are looking at how many sessions, how many customer conversions. So just information about, hey, how many times are our customers interacting with our product. So here, now you have, sorry, a little breath explaining all that. So here you have just some relations here just to say, hey, load it, then transform it. And then for our unstructured data, so kind of happening in parallel to all this, structured conversions, we have, go back over to the graph view, go into our unstructured data. You can see what's happening here. And before I go into code, I want to show you, first we're loading our unstructured data. So for our Twitter comments and comment training, these are just getting loaded and then transformed using pandas. For our load support calls to stage, we're actually, this is where we're using Whisper to transcribe those calls and then load them into a pandas data frame. So after we have loaded them into pandas, we're then going to use Weaviate to generate embeddings. So condense that information from just plain text stored in a pandas data frame into that kind of Weaviate embedding in a vector format before we then bring them to sentiment classifier. But if we go into the code and look at this task group, so down here in load unstructured data, so after we go back all through there, sorry, we have our, again, just a task group, and unfortunately it's not as simple as the load structured data. But here first we have within this subtask group of load unstructured data, loading our support calls to stage. So these are just within a local directory. So pulling them all in from support call zips file, loading them up into Snowpark. Then you'll see we are also, you can see loading support calls to stage, calling that. And then for the comments and training data, so the Twitter comments and just regular comments, we're actually just loading those using the load file function or load file task from AQL, which is the Astra SDK. You can see just loading from local Parquet files into Snowflake. Then returning all of those, and then here setting up our Whisper configuration. So we get NumPy, Torch, TQDM, more iter tools, transformers, that FFPMG to transcribe the calls, and then the version of Whisper we want to use, then transcribing those calls from our call recordings as obviously. And you can see then we're loading them up, just saying calls to data frame, extracting the customer ID for each call so we can then later join that to the customer ID on their spending later. And you can see just kind of all the information here where we're just saving the information on the transcript that we have transcribed. So if we go to calls df, whisper.load model, so then go into where's model use. Oh, here we go. Model.transcribe. So cool. This is using the dot apply to transcribe them, save them all in a data frame with customer ID and transcript. So they have customer ID and what their transcript was. Then pulling in all the training data. So just pulling in all the training data we just loaded. This is only really possible because we're using that Snowflake XCOM backend to be able to process larger data frames. So then we have our Snowpark Python task, getting our comments, getting our calls, the call transcriptions. Then finally, we're generating our training embeddings. So here we are converting that raw text into pre-built embeddings. So we're actually just using our preloaded embeddings, but in real life, what you would be doing is just saying, hey, take this raw text data, condense it into vectors. You can see here just kind of replacing it, condensing the data down, and then it'll return a data set with that common training vectorized, right? So it's become vectorized, embedded. Still getting a grip on this, but it basically just is condensing raw text data into a format that Weaviate can understand, computer speak. And so then down we have Weaviate import, generate Twitter embeddings. We're just doing a similar thing, generating embeddings from our Twitter data, then doing it for our call data, transcriptions. So that was actually our comments up here that we're transcribing. Then we are back to the graph. So we've got all of our data loaded. We've got our unstructured data. We've got our structured data loaded. So here, this is where you can actually, kind of have some more fun with it and switch out different models. So if we go open our train sentiment classifier task, so I'm just gonna scroll down to, I think it's like 700. So here, after we loaded all of our unstructured data, we have our train sentiment classifier. So this is kind of the crux of the whole shebang. So here, if you wanted to switch out a model, switch out LightGBM for whatever kind of classifier you want to use, maybe a random forest classifier. They're all tons of them available within the Snowpark ML model registry. So you don't have to build your own or do anything crazy there. Just build on the backs of giants. And so you can see the description here, task fetches embeddings for labeled dataset using the Weaviate data hook. So here we're importing a model, importing pandas, model information, our Weaviate embeddings, bringing out our Snowflake model registry, initiating a Weaviate client, bringing in all of our unstructured data. Then we are conducting a sentiment or bringing a sentiment classifier in, splitting our data into training and testing data. And then after that, we have our LGBMC classifier. So this is the classify, and this is another way you can switch out. If you want to switch out the random state, it'll give you a different prediction because it's kind of like a seed, like in Minecraft, where it's like a randomized state, but it's accessible by one particular integer. Then we have our model ID, so you have to register your model to the registry, and then it'll return that registered model, so with your testing data. And then now what you can do is go in to our next task group, which is scoring sentiment. You can see that over here. So within the scoring sentiment task group, you have call sentiment and Twitter sentiment. And this is where I hate saying sentiment so many times. But here we have within our call sentiment analysis, we're using that model registry, loading in our call data. So you can see getting the metrics, loading the model. So predict the probability of the sentiment based on that call data. So this is here, we're using that model. If we've loaded it in, you can see just bringing in our, up here, you have our, where is it? Yeah, just our Snowflake model registry class name. Then what this will return is a data frame that has the predicted sentiment values. And I'll go over to Snowflake UI in a second and show you all the finals results here. And then what we have is a Twitter sentiment analysis. So here you have similar option where we're just using that again, data frame where we want to predict for sentiment, predict probability, and since we've already split everything, already assigned our different data, we don't have to do any of that here. It's already been done in kind of that train sentiment classifier section. So here, predicting the probabilities for that, and then returning it as a data frame. And then see we have a predicted calls table, so we're creating new tables that are customer call, customer comment, running those two Twitter sentiment and call sentiment tasks, and then returning those values. And then just finally, in our exit task group, we are creating presentation tables, so consolidating all of our data results to create tables for a presentation layer running within the Streamlit app. And so if we go now over to our Snowflake environment, so I've already run this, obviously. It takes about 10 minutes to run. It's a lot, especially on the first time, it's a lot. But once it's all done and running, and I'll just start running it again just to kind of prove to you that this will actually work. Lord, bear me faith. Yeah, so this will just start running in the background. And then if we go over into our environment here, refresh. Here we have our demo database that was created in those setup tasks. You can see our predicted customer calls here. So here in our data preview, if we look at it, you can see our customer ID, transcript, vector image. You can see the predicted sentiment of this call. So you can see all that information within your Snowflake environment. And then if you want to create a Streamlit app on top of this, actually check out my previous videos on how you can create Streamlit apps off of your Snowflake data, because this video, I just realized, is 25 minutes long, so I will cut it here. But I really hope you learned something. I hope you go in here, change it up for your own configuration, play around with it, and it just gives you a good kind of context of, hey, this is what it looks like to actually create a production machine learning pipeline. And so, without further ado, if you like this video, please like and subscribe. And no matter what, data guy out. Have a good one. Peace.